Most panels today get upgraded because there is too few circuits, not enough amperage, or my favorite, they burn up. No need to worry. I'm here, and this is my goal, to make sure that this does not happen to my customers. I feel that it is essential that my customers trust and rely on their electrical systems. In this video, I'm going to be going over the steps I take to perform preventative maintenance for my customers. There is only 3 steps to performing preventative maintenance. 1. Visual inspection. 2. Mechanical servicing. 3. Electrical testing. As seen here, I am now performing my visual inspection on this panel. I am looking for external physical condition, the inspection of the grounding and the anchorage of the panel itself, the verification of breakers, breaker sizing, the right type of breaker, the connection on the breaker, and the cables that are hooked on the breaker, the verification of the insulation on the cabling, insulation on the bus, and the last thing is to verify that barriers and safety precautions are in place. This is extremely important. In this panel, there is some particular issues that need to be addressed. Starting with the 2 breakers on the bottom left hand side, need to be a 2-pole instead of a single on a multi-wire circuit, and the tandem should not be installed in this type of panel. Also should be a multi-wire circuit as well, so a 2-pole breaker. Before moving on, I always make sure I have all the tools to provide the electrical testing and mechanical servicing. The next step I perform is step 3, electrical testing. I don't do mechanical testing first because I like to see the panel being on, and part of mechanical testing is turning the breakers on and off. Step 1 of electrical testing will be checking the connections on the hardware. To check all the connections on the hardware, I use my IR scanner. This is a thermal device that will tell me if there's any loose connections or damaged connections. Only if there is a load on that service, which everything is on in the house, so there should be a load. Next step that could be critical in some panels would be to check the resistance of the main bus, maybe check the resistance of control wiring. But most residential panels, the next step would truly be just to test protective devices like GFCIs and AFCIs. I like to go back to step 1 and go back to checking all the hardware connections. Using my voltmeter here, this will tell me how the connections are doing electrically as well. So phase A is going to be a set voltage and phase B is going to be a set voltage. Any deviation from that lower will tell me that there is some connection in that breaker or in that setup that's causing an issue. I need to look into it further. So like phase A here should be 123.7, and so you're kind of looking to have all of them on that same number. Now a touch higher is usually okay, but lower means there's an issue with that breaker or that connection in that spot. Maybe the bus, but that means that one needs to be looked into first. The next thing I would check is that the voltage is proper coming into the home, and on the 2-pole breakers you're looking for 3% of 240 volts, and a little bit higher is always better than lower because it still has to travel to the end device. As it travels to the end device, the voltage will go lower. The voltage of this panel will go down on hot days and when there's a lot of load on the panel. Also, therefore, the voltage will be way high in the winter when it's cold outside and there's not a lot of load on the panel. It also wouldn't hurt to check amperage on this panel just to see what it's at, but there's nothing large in this panel, so I wasn't very concerned with it. The last crucial step in providing preventative maintenance for this panel would be mechanical servicing. As I stated earlier, this is step 2, but I always do it as step 3 for residential panels. The first step is to check the mechanical condition of this panel. This would be like how it's mounted, the bolts holding the panel in place, the bolts holding the bus back, the screws holding the neutral bar, and last but not least, like the lock nuts holding all the connectors in place. Next step is you want to ensure you have the proper tools to service this panel. I think I went a little bit backwards here because the 4th step is mechanically operate the circuit breakers in this panel, but I decided to skip that and go to step 5, which was inspect voltage connection integrity, which is what I'm using my torque screwdriver here to tighten up all the connections. The connections on the neutral bar in this panel were set to 32 inch-pounds. Almost all of the breakers were set to 30 inch-pounds. Besides the main was set to 50 inch-pounds. The ground lug 41 inch-pounds. And finally, the neutral lug was set to 50 inch-pounds. Now that everything is tight, back to step 4, mechanically operate circuit breakers and switches. We want to make sure everything operates functionally in the proper way. And if these haven't been off in a while, it wouldn't hurt to turn them on and off more than once. I mean, the whole insides on these breakers, it's great to operate them. Helps keep them clean, keep them corrosion free, and making sure the springs and everything are still operating in the correct condition and the right order. Most manufacturers recommend doing this once a year. In residential services, you will find interlocks, maybe sometimes with solar or with generators. These are extremely important. You want to check to make sure they're installed properly and that these interlocks are functioning the proper way. If they are not installed, they need to be installed. Finally, the last step of mechanical servicing is to clean the panel out. Clean the breakers off. Make sure everything is in a clean and tidy order. You want to make sure that the panel is looking close to new as possible. This is stated in condition 1. Also, in condition 1, it's ensuring that the enclosure is clean and free of moisture intrusion and tight, has no addressing issues if connected to the internet, has no active recommendations for preventative maintenance. Last but not least, has been previously maintained. So most of the panels I work in are condition 2 because they have not been maintained previously. The panel would also be in condition 2 if the maintenance results deviate from past results from being here before. Example would be is if I find a hot spot in this panel next time I come back. The last thing that would make a panel condition 2 is those active recommendations for preventative maintenance or predictive techniques. An example of this would be to have to replace those breakers, the 2-pole breakers in this panel. The third condition this panel could be in is if the panel missed the last 2 consecutive maintenance schedules, if the panel has required repairs on the last 2 schedules, and most importantly, if there's urgent actions identified by the maintenance that is completed. One day, this panel will become non-serviceable. This meaning it would be imposing imminent risk of injury or negative health effects on personnel. One day, they all get that non-serviceable tag stuck on there. Then it's time to upgrade. Thanks for watching.